Hi guys, my name is Ra. In this video, we will discuss about gas turbine engine thrust reversers and thrust augmentation to be discussed by Hubert. Let's begin with the gas turbine engine thrust reversers. Reverse thrust is thrust projected in the opposite direction to normal and is used to decelerate an aircraft after landing. In the event of a rejected takeoff or in some limited cases in flight. There are three types of thrust reversers. The first one is target thrust reverser. A target thrust reverser is a reverse thrust system most typically installed on turbojet and low bypass ratio turbofan engines. This is a hydraulically actuated system that uses bucket-type doors to reverse the flow of the engine hot gas stream. The second one is clamshell thrust reverser. This design was specifically developed for turbojet engines. It is essentially two outer exhaust nozzles that can be unhinged in a manner that the two nozzles combine together to block and redirect exhaust flow after it leaves the turbine section. Many thrust reversers have clamshell doors, which open and close at designated moments. This will to slow down after landing. The aircraft engine itself does not run in reverse. Rather, the direction of the engine's fan airflow is reversed, creating a massive drag. And the third one is Coldstream thrust reverser. This bypass air produces reverse thrust when activated by an air motor. While the plane is in flight, the reverse thrust vanes are blocked by doors that fold back when the pilot deploys the system. This blocks the nozzle and the cold stream and redirects this airflow to the vanes. Thrust reverser systems are commonly found on passenger airplanes and large cargo jet aircraft, while some aircraft, such as military planes, may use it while in the air to perform steep descents. Reverse thrust is typically only used when on the ground. Private and commercial aircraft feature safeties within the system that prevent the thrust reversers from deploying when the aircraft is in the air. You see that this part of an aircraft is very important because by acting against the aircraft's forward travel, a thrust reverser system helps the jet slow down just after touchdown. This reduces wear on brakes and facilitates shortened landing distances. Thrust reversers are considered essential to an airplane's safety and performance.
Thrust augmentation, the technique by which the basic thrust of the jet engine can be increased without increasing the size of the engine. Basically, there are two methods: afterburning technique and water or alcohol injection technique. Afterburning is achieved by mixing the bypass and turbine streams before injecting the afterburner fuel. In the case of the jet engine, the engine burns fuel, like kerosene with air, from the atmosphere to create thrust. Most modern jet engines use a turbine to improve their efficiency and allow the engine to work at low speeds. One part of the engine sucks the air and compresses it before the fuel is injected. The back portion of the turbine acts like a windmill, extracting energy from the exhaust gases. An afterburner is nothing but a set of fuel injectors, a tube, and flame holder that the fuel burns in an adjustable muzzle. The idea behind an afterburner is to inject fuel directly into the thrust stream and burn it using this remaining oxygen. The advantage is that it can significantly increase the thrust of an engine without adding much weight or complexity of the engine. A modern turbine engine is extremely efficient and there are still a lot of oxygen available in the exhaust system. A jet engine with an afterburner it needs an adjustable nozzle so that it can work both with afterburners on and off. Afterburners are commonly used by military jet planes when taking off from a short runway or on an aircraft carrier or during the high-speed maneuver in the dogfight or in the basic flight of the jet engine. Water injection is one of the simplest methods of augmenting the thrust of the jet engine. Using this technique, power or thrust up to 30% can be boosted for takeoff. This technique is mainly used when there is a drop in the thrust due to changes in the atmosphere pressure or temperature. They are usually injected at the compressor input or shortly before the combustion chambers in the diffuser. This increases the mass being propelled out of the engine, boosting thrust while also cooling the engine blades. That's it, and I hope you understand, and thanks for watching.